Again. Work in progress. Okay. So kita cakap pasal errors tadi, right? So we talked about personal errors, biases in observation. This is under personal error. Biases in observation ni under personal error. And then errors in reading scale. Also kita bila mata kita tak selari dengan scale dia, scale yang kita tengah tengok tu, then that will also cause a personal error. This is called, I forgot what it's called. Reading error skill. Ada nama yang korang belajar waktu high school tu, I forgot already. But this is also under personal error. And then we have systematic error. We have systematic error whereby it can fall under an improperly zeroed instrument or personal bias of an observer. So improperly, kejap, anak saya ni main almari pula. Yusa, sini kejap. Take this one. Yeah. Okay. Okay, so systematic error and improperly zeroed instrument such as microammeter or ammeter. Okay, let's use a weighing scale lah. Lagi senang kot kita boleh relate. So weighing scale rupa Allah dia. Weighing scale kan bila kita tak duduk atas weighing scale tu, it should show a zero, right? But sometimes when the weighing scale dah lama ataupun lama tak pakai, so the weighing scale starts at some value. Contohnya like dia start dekat 0.5 kilogram. So when saya duduk atas weighing scale tu, it does not give me an accurate value lah because it started at 0.5. Yang sebenarnya it should start at 0. So this is called improperly zeroed instrument. So what you should do is you need to calibrate. The word is calibrate. Kena calibrate balik the weighing scale so that it shows to 0. And this applies to every equipment that you are using. You must always observe it if it is starting at 0 or not. And how is this relevant? Because we're not doing experiment in the lab, right? So simulation pun kadang-kadang it does not start at 0. So you have to be aware of what is the 0, how to make it 0 lah, go 0. Okay, and then we have the personal bias of an observer. For example, always taking low reading of a scale division. So this is systematic and also personal error lah. Okay, we saw this earlier also. And then we have random error, which results from unknown and unpredictable variation. Contohnya daripada environment. Contohnya, I am measuring the temperature of a water and the temperature of the water should be 60 degrees. But because it's so hot outside, air tu cepat sangat dia jadi panas. So instead of 60 degrees that I'm trying to achieve, I get like around 61 or 62 because of the hot weather outside. So 60 pun dah panas kan? So dia macam bertambah panas lah. So this is what happens from random errors lah. The environment influences your data. Okay. So these are the errors that you should discuss in your discussion of your lab report. You need to identify what are the errors that might happen or might occur when you are performing your experiment. Okay. So contohnya kita akan buat graphical analysis today. And for the graphical analysis, you will either use you will need to draw graphs, right? For graphical analysis, you lukis graph lah. So you lukis graph, either boleh pakai Excel ataupun boleh lukis pakai kertas graph. If you are using a graph paper and you're using a ruler and a protractor, so what are the example of error that can happen kalau kita pakai kertas? Can anyone tell me? Kalau kita pakai kertas graph, apa error yang boleh jadi? Kita nak lukis graph ni.
Mata pensel besar sangat. So nanti graf tu macam lari.
Betul, boleh? Yes, boleh jadi. Any other errors? So kalau mata pensel tu besar sangat, what error does that fall under? Is it a personal error? Is it a systematic error? Or is it a random error? Tu nanti kena figure out lah. So baca yang ni, try to figure out which error does it fall under. Okay, other errors? Contoh lain? Kalau kita pakai kertas graph and pakai ruler, pakai protractor, what will happen? Personal.
Tangan menggeletar.
Apa dia?
Tangan menggeletar.
Tangan menggeletar, okay. Itu kira personal error lah. And then mata scale tak betul. Kadang-kadang kita tengok dari jauh kan. Tengok dari jauh, ruler tu kat hujung sana. Kita kat sini. Lepas tu dah reading dah salah. So that is also a personal error. Okay, so I think you guys get it. So use this PDF to identify what are the errors that could occur in your experiment. Each time, each report, kena ada discussion on the errors apart from the theory, apart from the equation. Okay. So what else should I cover in this document? Okay, significant figures is very important. The number of significant figures in a number is a number of physically meaningful digits. Okay, meaningful digits. For example, sekejap, saya ada check kat sini. Oh, woo. Okay, tak ada. Let me write. Where is my pen? Oh, it's here. Okay. So dia cakap kat sini physically meaningful digits. I think you've learned this before, but it's okay. Let's just go over it again. So for example, I have 150.5. So the meaningful digits here is 1, 5, 0, and 5. So it's 4 digits, right? 4 digits that is meaningful. So I have four significant figures here for SF. Susah nak tulis. Okay, so that is 4 significant figures. But usually we will ask you to have like minimum 3 significant figures. Minimum. You can go beyond 3 significant figures. And typically, kejap anak saya main game bisingnya buatanku. Please grant me patience. Kejap So, can you go out please? Why are you being noisy? Bye. Okay, sorry, banyak gila gangguan. Keep myself over here. Okay. So typically we ask you for a minimum of 3 significant figures, but if you want to go beyond 3 significant figures, boleh. Okay. 2 decimal places, 2 decimal points. Okay. Okay, so when reporting numbers, always include as many significant figures as the uncertainty allows. Okay, so what is uncertainty? So uncertainty ni benda alah ni lah, plus minus 0.2. So if you are giving me a plus minus of 0.2, so your number over here should be 1 decimal point lah. Kat sini 1 decimal point, right? So 1 decimal point over here as well. And then, but never y equals to 2.6667 plus minus 0.1. So dia tak tally kat sini. Sini ada 1, 2, 3, 4, 5. Kat sini ada 1. So tak tally lah. So you have to, if you are giving me uncertainty, the plus minus value, it should follow, your value tu kena follow lah uncertainty tu. And then this is the correct way, 27 plus minus 3. Sebab sini tak ada decimal point. So kat sini pun tak ada decimal point. So tally lah. And then 4.56 plus minus 0.03, betul. 2 decimal places, 2 decimal places. 0.002, so this is 3 decimal places. Plus minus 1, 2, 3, 4. So this is 4. Boleh sebab dia boleh jadi macam ni. Okay. Basically if your, how do I say this? Dia kena tally lah. Okay, so if kalau kita tengok example yang wrong, this guy does not have a decimal place, but your uncertainty ada. So it should be 25.0 plus minus 0.2. Should be like that. Okay. 0.0023. Meaningful digit. 1, 2, 3. Okay. Okay, basically kena sama lah decimal points dia. Kat sini tak ada decimal point. So your uncertainty pun tak ada decimal point. Make sure it tallies for your data. When you write an uncertainty, you should never include more than 1 or 2 significant figures because in general, uncertainties are not known precisely enough to report 2, 3 significant figures. So write delta x equals to 0.4 centimeter or sometimes delta m equals to 0.15, but never go for 3 significant figures. So kat sini dia kasih 1 significant figure, kat sini dia kasih 2. Dia cakap jangan kasih 3 sebab susah. Nanti data yang terlalu precise ni selalunya error juga. Bukan, I shouldn't say it like that lah. it will cause you trouble lah. I wouldn't say it's not accurate, but it will cause you trouble later on when you have too many significant figures for your uncertainty. This is specifically uncertainty, uncertainty, 1 or 2 significant figures. Okay, take note on that. Okay, a number like 45,000 is ambiguous, is that you cannot tell how many significant figures it has unless you give it the uncertainty. Okay, it might mean 45,000 plus minus 1, in which case it has 5 significant figures. Or it might mean 45,000 plus minus 1,000. Then it only has 2 significant figures. Sebab yang berubah kat sini ialah 1,000, right? So 1,000 is only here. And this guy, these two numbers je, these two digits je yang jadi meaningful. Kalau kita pakai 1, then all of this becomes meaningful. Sebab kita tambah 45,001, 45,002, 45,003, and then dia boleh naik sampai 46,000. So semua digit dalam tu jadi meaningful. Whereas 45,000, when your uncertainty is 1,000, dia akan naik 46,000, 47,000, 48,000. So belakang ni dia jadi tak significant, dia jadi not meaningful lah. Okay, so in this case, only these 2 digits become meaningful. So your uncertainty will affect your significant figure. So this is why they say go for 1 or 2, but never 3. Dia leceh ha. Okay, to be clear, you can either include the uncertainty or write it in scientific notation like this. 4.5 times 10 to the 4. In this case, you have 4 significant figures. This document will be provided to you if you want to go over it. If this is not clear enough, you can Google. Boleh baca orang lain explain macam mana, if that helps. Okay. Alright, so that is done. Let's go over to your lab report. Do I have any questions so far? Is everyone okay? Doktor, macam nak tahu uncertainty? It depends. Okay, that's a good question. It depends on your measuring equipment. So for example, your weighing scale. Your weighing scale typically gives you 2 decimal places, and which gives you, contohnya saya, alamak, saya nak bagi tahu berat saya ke? Okay, 48 lah. Contohnya 48. And then my weighing scale has 2 decimal points. So it becomes 48.57. So in that case, I have 4 significant figures. And because my weighing scale is very accurate and it gives me up to 2 decimal places, so my uncertainty becomes, kejap saya nak share screen dulu. Okay, weighing scale lah. Mana saya punya pen? Draw pen. Okay, so my weight 48, tak tahu, saya tak ingat. Okay, plus 48.57 was what I measured on the weighing scale. And because I measured it like this, and if my weight fluctuates, right, if it fluctuates, it can fluctuate from 48.40 to 48.6. So I fluctuate between 48.4 to 48.6. But right now, what I'm reading on the scale is 48.57. Dia tak tally lah pula, kejap. 13, 7 lah, 70. 1, kejap 60, 70. 1, 3. So this becomes 4, 4, 4. Okay, betul good. So my weight fluctuates from 48.44 to 48.70. But the one that I'm seeing right now is that, so my uncertainty becomes 48.57 plus minus 0.13 if I'm calculating this correctly. Okay, so I have 2 decimal places here. And what is the meaningful digit here? 4 significant figures. Okay, itu contoh. What if my weighing scale is like old school gila and it only measures like 1 kilogram, right? Up to 1 kilogram. So my weight is supposed to be 48. Contoh ni bukan weight saya yang sebenar. 48 kilogram. I'm reading the scale and it shows me 48 kilogram. But on other days, it fluctuates to 49 kilogram, kadang-kadang it goes to 50, kadang-kadang it goes to 51. So it fluctuates by plus minus 1. So 48 plus minus 1 kilogram. So what is the significant figure here? It is only 2 instead of the 4 that we observed earlier. Okay, it depends on your measuring equipment. Does that make sense? Okay tak? Is that confusing or okay? I think a lot of people are confused.
Okay.
Okay, so it depends on your measuring equipment. Tengok decimal places and tengok the significant figures. Okay, ringannya no, itu bukan saya punya sebenarnya. Okay, Doktor cuma nak tahu uncertainty. Okay, saya dah jawab soalan ni kan. Okay, let's go over the lab report now. So this is our first experiment to find out how to plot the best fit line and then to interpret and analyze data in graphical form. So in physics experiment, we normally need to consider the relationship between the data obtained. Okay, the graph is an effective way for representing the relationship between variables. Okay, so if you have X and Y, so a graph can tell you with increasing Y, my Y also, with increasing X, my Y also increases. So this is what the graph is telling me right now. So if my graph is like this, with increasing X, my Y goes down. Macam tu lah. So that is why graph is very, very useful for physics, in physics. Okay, so the simplest and most common is the straight line or linear graph. Any straight line XY graph obeys the common equation given as y equals to mx plus c. So this is your straight line graph. Okay, so kalau nak pakai graph ni, dia memang akan jadi straight line. Memang, confirm. Takkan jadi curve, takkan jadi wiggly sebab this is a straight line graph. Straight line punya equation. Okay, kalau dia nak jadi, apalah, kita tak akan cakap pasal non-straight line. Oops. Okay, so let's take a look at this. Here M is the gradient of the graph. What is gradient? Gradient ni kecerunan. And what is kecerunan? Gradient is M delta X, the change in Y over the change in X. So delta means change. Always, when we see a small triangle like that, it's called the change in Y and change in X. Okay, so gradient always gives me the change in Y over the change in X. So how do we calculate that? So for example, this is 5, this is 3, and the X value over here is 2, and the X value over here is 7. So to calculate the gradient, M equals to the change in Y over the change in X. So in this case, the change in Y, so it goes from Y, it goes from the yang hujung, final Y2 minus Y1 over X2 minus X1. So what is Y2? Y2 is here, this is X2, and this is X1, this is Y1. Okay, so Y2 in this case is 5, and then minus with Y1, which is 3, over X2 is 7, and then you have your 2 over here. So you get 2 over 5. So this is your gradient, okay? And can you make your calculation of your gradient smaller? Boleh. So in this case, you will have a different Y punya value, but it will still give you the same answer. You can make it bigger than this guy. You will get a different Y and XY value, but it doesn't matter as long as the gradient is referring to the same line. You will get the same value. Okay. So that is how you calculate for M. And then what is C? C is the Y-intercept. Y-axis intercept. Okay. So kalau kadang-kadang your graph extends like this. So here it doesn't intercept the y-axis, but in reality sebenarnya this y-axis extends downwards. So you still get an intercept, but it is a negative value, negative c. This guy is a positive, this guy is a negative. So boleh it can go down here and it must touch the y-axis. That is your c intercept or your y-axis intercept. What else do I need to tell you? Okay, I think that's it. So y equals to mx plus c. So this is your y data and this is your x data. X is the manipulated variable. Y is something that you can't control. X is something that you can control. Okay, X manipulated. Basically, this is you control. Control value. Control values lah. The ones that you can put in. And then this is the dependent. Manipulated. And this is the outcome lah. Basically, this is what the result you are expecting. Okay, so let's go to this equation, an example. So the velocity of an accelerated linear motion is given by v equals to u plus at. But before that, do I have any questions so far about y equals to mx plus c? Is everyone okay? Dah belajar kan? Kita semua dah mengantuk dah.
Yes.
Okay,
Okay.
Okay, so kita ada equation kat sini. V equals to U plus AT. This equation is in the form of a straight line. Okay, so any straight line should fit Y equals to MX plus C. So how do we, macam mana kita nak tahu V equals to U plus AT ni, mana satu Y, mana satu X, mana satu C, and mana satu M, right? So here, a graph of V versus T is a straight line. So dia dah kasih hint kat sini. A graph of V versus T is a straight line. So here, a graph of V versus T is a straight line. I don't know how it looks like. Maybe macam ni. So immediately I already know that my V is the Y and the T is your X. So if I were to rewrite this to follow this format, so this would be V equals to AT and then plus U. U here, AT over here. So AT plus U. So because my T is my X, right? My V is my Y. So my C becomes my U. Sorry, my U becomes my Y intercept. And therefore, my acceleration or A is the gradient. So this graph will tell me the acceleration. Okay, this graph will tell me the acceleration. Is it important to rearrange your equation into the y equals to mx plus c? For starters, sometimes it is hard to identify which is the gradient. So I would recommend for you to rearrange your equation into this format so you know which one is your gradient. Sebab gradient ni benda yang kita nak cari. Okay, so other examples. Sekejap, I nak take a break. Okay, for other examples, for example, this equation, n equals to n naught, sebut dia n naught. Macam naughty, but it's not, not je. N naught. Okay. So n naught equals, n equals to n naught exponential minus lambda t. Right? If I were to rewrite this, n naught e. Saya punya pensel ni tebal pula dah. Kejap So it's hard. So n naught e to the power of minus lambda t. This is another way to write it. So when we see this equation, we know that it is not a straight line. Sebab apa? Ada exponential ni. E is never a straight line. So how do we make it a straight line? You have to convert it to become a straight line by taking its log. Okay, So when you take a log of this equation, it becomes a straight line. So kita dah buang exponential tu. So this becomes when I put in log over here, I need to put in log on the other side of my equation. So this becomes log n. Okay, log n equals to log n naught. Okay, log n naught, and then log exponential minus lambda t. So if you guys remember, log cancels out with exponential. So this leaves me with minus t. So this now becomes log n naught minus lambda t. Okay. Yang sebenarnya tak ada bracket ni. It's just to menyenangkan korang tengok. Okay, log n naught, and then this cancels out, so it becomes minus lambda t. So now that the exponential is gone and it became log, now it is a straight line, and this is what we want. Okay, so now I can try to write this in the format of y equals to mx plus c. So let's try it. Y equals to mx, mt dah. mx plus c. Okay, so now you have to remember that c is always a constant. Always a constant. Ataupun value lah, or a value that does not change. Not change. Okay, so if we are looking at this equation, biar saya buang ni jap sebab sangat semak. If we are looking at this equation, which one looks like the c? Can anyone tell me? Which one looks like the c? Apa yang value dia takkan berubah? No one wants to try?
Lambda t.
Lambda t. Okay. So thank you for that answer. Any other guesses before I explain? Any other
Log
guesses?
n naught. Log n naught.
Log n naught sebab? Sebab apa?
Lambda dia negatif.
Sebab lambda dia negatif. Okay. Any other guesses? Okay, I like the guesses. It's very I like it. Walaupun salah, tak apa. Kita kat sini belajar.
Log n naught.
Log n naught. Okay, why? Cuba je, salah tak apa.
Same with y except y axis.
Sebab dia dekat y-axis. Okay. So what, okay, my question to you now. So what is the condition to become a y-intercept? What is the condition? Can it change in value? Okay, bila saya ada graph, kan, bila saya ada graph, so it intersects somewhere. Does this place change?
No.
No, it's
No.
apa yang takkan berubah dalam equation ni?
Log n.
Log n,
Log n naught.
yes. Log
Log
n naught is something that will not change because n naught is a constant. So log n naught is your c, but that is the only thing that does not change in this equation. So t boleh berubah, t is time, n is a variable as well. So not, when you see this how do I say this? N naught is something that n at initial point. Kita tahu kan, benda yang rupa ada kosong kecil tu is the initial point or a constant. So this is the only guy that is a constant in this equation. So this becomes the c. And then this is, so that is your c. Hello, apa yang berlaku ni? Okay, so this becomes y equals to mx plus c. And if I rearrange this, log n equals to minus lambda t plus log n naught. So your n naught is your c, your log n is your y. And what about your gradient? What is your gradient here? Is it t or is it
Negative lambda.
Negative lambda.
It's the negative lambda because t is your manipulated variable. Selalunya macam tu. Memang time is your manipulated variable. Okay. So if you find this confusing, tak apa, kita ada banyak lagi exercise and you will do it for your lab lah, okay? So choice of axis and scale. A common approach to the choice of a graph is to plot the manipulated quantity on the x-axis and the dependent quantity on the y. So like I said before, this is something that you can control or the one that you are supplying the value. And this is the outcome from your equation. Outcome, because y equals to blah, blah, blah. Y is your outcome. Okay, we need to plot the t versus t graph. So when they say t versus t, so this is always y versus x. Selalunya macam tu, conventionally. Dia akan cakap y versus x. So if I say force versus, sorry, force versus time. So you know that this guy is your y, this guy is your x. So that is the conventional way of describing your plot. Okay, so what else? Scale. A good graph should cover at least half of the graph paper. Okay, so your graph paper looks like this, right? Okay, so you plot it lagi besar, lagi bagus. Minimum separuh. But if your graph does not fit and you want to draw it horizontally, pun boleh asalkan lebih dari separuh kertas graph. Boleh. Nak landscape ke, nak portrait mode ke, boleh asalkan lebih separuh graph. It is not necessary to start at the 0, 0 point, but it should show all the experimental data points. And kita akan cakap pasal data points in a bit. Choose a convenient scale so that the data points can be easily read. Okay, for example, I have my x data and my y data. And my x data is 0.16, 0.17, 0.18. And then my y, which is the outcome that I'm getting from the equation, is 0.0006, 0.00069, 0.00071. So in this case, if I want to put it inside this graph, boleh, tapi it becomes difficult and macam nak cakap, susah nak baca kan, susah nak baca. So how can I do this so that it's easier for me to read it and easier for your instructor to read it, is you write it in scientific notation. Okay, so 60, 69, 71 times 10 to the 1, 2, 3, 4, sorry, 1, 2, 1, 2, 3, 4, 5, 5, 1, 2, 3, 5, yes, 5, minus 5 times 10 to the minus 5 times 10 to the minus 5. So you don't have to put in the minus 5 here. So how can you do it? So like this is your graph. So 60, 69, sorry, 70, 80. So this is your data 60, right? Contohlah 60 kat sini. And then you have a 69. And then you have a 71 over here. And then you can put in your scale. Let's say this is time. No, I don't want it to be time. Tak sesuai. Let's say it's length. Kecil sangat pula. Tak apalah. Length lah, letaklah length eh. So length. Sorry, length. This is not y. Sorry, I'm doing y, but I'm putting it in x. So sorry. So this is length. And this is length versus force. Okay, so y is a force. So this becomes, let me plot this properly lah. Sekejap. Give me a moment. Okay. I think we should do it somewhere else because it's getting crowded. So my x is length, right? Okay, length. And then the unit is meter. And then the force is the y. Force. And this guy is in Newton. And then I told you this guy is hard to read. And I recommend you to do the scientific notation. So how should you put in the scientific notation in your graph, right? So 0.6, 0.16, 0.17, 0.18, and then the data is 60, 69, and 71. 60, 65, 70. So 60 over here. And then you have your 69 over here. And then there's a 71. Terlebih sikit kat sini. That is your data points. And then how should you put in the times 10 to the minus 5 over here, right? You can put it in here. Oops. Times 10 times 10 to the minus 5 Newton. You can put it like that. Asalkan seragam. So if you don't want to put 10 times 10 to the minus 5 and you want to put times 10 to the minus 2, boleh. But this guy kena tukar lah to become 6 something, I don't know. You have to adjust accordingly lah. So if one data is using times 10 to the minus 5, all the data in your Y should have the same scientific notation. Okay, so that you can plot it here. And then your scientific notation goes inside here, or you can put it over here. Boleh. Tapi leceh sikit lah kan. So better put in your axis. Okay, I hope that is clear. Nanti kita akan cuba buat example lagi. Okay, so this was your X data. This was your Y data. Okay. All right. So next thing is to talk about centroid point. So, okay, it's here. So what is centroid? Centroid is the center of the graph. Centroid is the center of the graph. Okay, ni dah macam dia kacau. Let me remove this. Kita akan buat kat tempat lain nanti. Okay, so centroid is the center of your graph. So how do you find out what is your centroid? So you have like a bunch of data, around 6. So you have data, and then you put in your best fit line, right? Best fit line, and then the center of your graph is indicated by this value. Sorry, by this sign. It's a circle with an X inside. Okay, like this. This is called the centroid point. Okay, and you calculate it. Kena kira You calculate it by summing all your x's, dividing it by the total number of points that you have. Total number of points. Okay, so n refers to the total number of data points that you have. This is the sum. Okay, ni symbol sum. Okay, so for a straight line, the best fit line should have the same number of data points on each side. The best fit line should have the same number of data points on each side. What does this mean? So let's look at this graph. Okay, so I have data here, data. And if I want to draw a straight line, the straight line will not be overlapping my data. So how do I do it? So if I wanted to overlap all my data on my line, it's not possible. Okay, so when it is not possible to overlap your line on top of your data, you just plot in your best fit line. So how do you draw a best fit line? Your best fit line should have an equal amount of data on the bottom of the line and also on the top of the line. So here you can see that there is 1, 2, 3 data points below the line and 1, 2, 3 points above the line. And then so that is how you put in the best fit line. Dia tak semestinya overlap dengan data. As I mentioned to you before, when you do experiment, there's a lot of errors involved and your data might not be 100% accurate. So the best fit line tells you the relationship yang kita nak tahu, yang kita nak prove in the experiment. This straight line gives us the relationship. Walaupun dia tak overlap dengan data, it gives us the relationship, and that is what is important sebab kita nak tahu equation dia apa, y equals to blah blah blah. Okay, So this is how you get the gradient, your centroid. So let's talk about your centroid again. So in this case, let's figure out the data here. So in this case, this looks like 0.3 or 2, 0.2 maybe. And this is a 3. So that is your first data, X and Y. Let's make our table over here. So our first data is 0.2 at the X and 3 in the Y. Then this guy is 1.2 maybe. And this is 8.
Doktor, Y dia bukan 13 eh?
Y dia bukan 13. Oh betul. 13. Thank you. And then this third data, we'll have a check over here. Doktor boleh ke kalau bahagian atas line 3 data, bahagian bawah 2 data. Kalau your data points ada 5 sahaja, boleh. In this case, kita ada 6. So 3-3 lah kat bawah. 3 kat bawah, 3 kat atas. But in the case that your data points is not nombor yang genap, boleh. Okay, 1.2, 18. Lagi soalan tak? Yang pasti jangan macam graf SPM. Graf SPM macam mana? Saya tak tahu graf SPM rupa macam mana. Trust betul. Okay. Kenapa ya? SPM punya graf macam mana? Okay, so this is 2.1 and 32 maybe, don't know. Kita just buat data dulu. And then this is 3. This is not actually 40, so it's like, saya tak tahu lah ke mana. 35 kot. This is 3 and this is 3.8, 40. Okay, sabar dulu saya tengah buat data point ni. Nanti kita nak buat pakai untuk centroid. This is not 5. This is 4.8 maybe. I don't know. And then this is 48. Don't know. Maybe. Okay, so that is my data points, rough estimation for the purpose of finding the centroid later. Okay. So now I have 6 data. 1, 2. I have 1, 2, 3, 4, 5, 6 data. So my n is equal to 6. What about my delta x? Delta blah. What about my sum of x? So my sum of x is 0.2, 1.2, 2.1, 3, 3.8, 4.8, right? So I don't know what that is. So let's calculate. 0.2 plus 1.2 plus 2.1 plus 3 plus 3.8 plus 4.8. Can anyone calculate this for me as well? Sebab saya rasa saya salah kira. 0.2, 1.2,
15.1.
15.1. Thank you. What about y? So y you get this guy. 13, 18, 32, 35, 40, 48.
186.
186. Kenapa saya selalu dapat salah? Oh salah betul. Saya salah. Okay. 186. Okay. So your centroid is x, y. This is the symbol. This is the mathematical notation of centroid. Equals to x over n, sum of y over n. Okay. So this becomes 15.1 over 6, 186 over 6. Okay, can someone calculate this for me as well? Jadi kita akan tengok dia tengah-tengah ke tak? Sepatutnya tengah-tengah lah. Sepatutnya. Okay, so what's the answer for this? 15.1 over 6.
2.52, comma 31.
31. Okay, let's see. So the centroid is 2.52, 31. 2.52 and 31. So let's see. 2.52 is around here. Kenapa saya punya graph macam tu? 2.52 and 31. Yay, we got it. Okay, so that is how you calculate for your centroid, assuming that they don't give you this table. Okay, assuming that they give you this table, sorry. They give you this data, you have to calculate what is the centroid point. Selalunya dia akan kasih table dengan kasih data, and you have to plot your data like this, and then put in the best fit line, find the gradient, find the centroid, etc. Okay, so now let's talk about this graph pula. So this graph, dia ada t squared, and this is L. And the L ada scientific notation. This scientific notation we already discussed, and I told you it's okay to have it like that. What about this graph? Can it be t squared? Boleh ke tak boleh sebenarnya? Boleh ke tak?
Boleh.
Boleh sebab
Cuma nanti dia punya relationship L directly proportionate to T square lah. Kan?
betul? Okay, betul jawapan tu. So t square ni boleh asalkan it gives me a straight line graph. It gives me the relationship dalam bentuk yang linear. So saya boleh y equals to mx plus c it can be applied for this graph. So your y becomes t squared. Your y becomes t squared. Saya tak tahu kenapa tulisan saya buruk ni. Y equals to mx plus c, so it becomes t squared equals to we don't know what the gradient is, it didn't mention, but we know that our x is L. So m unknown, L, and the c is just c lah, plus c, whatever that value is. Boleh, asalkan it gives me a linear relationship. Okay, so the point of using this y equals to mx plus c is having a linear relationship graph. Linear relationship maksudnya straight line lah. Okay. So this is your exercise. The following are the relationship between two quantities. Suggest the straight line graph to be drawn. You suruh suggest and then fill in the answer in the worksheet. So suggest, sekejap. What is the graph to be plotted? Sketch your graph here. Sama ke soalan atas ni? Okay. So dia dah kasih kat sini, manipulated quantity is your x-axis, dependent quantity is your y-axis. This is the quantity to be calculated, which is your gradient, m. It's not your c. So in this case, it looks, kalau kita ada square root, will our graph become a straight line or not? If we have a square root, will our graph become a straight line or not?
Square root, boleh.
Square root boleh. Okay, kita cuba. Tapi saya tak ada data lah pula. How do I show this? Do I have any other questions? Terbuka. Doktor kena berapa decimal place? Minimum 2. Selagi boleh lah. Kalau in this case, yang ni 3 kan? So pakailah 3, ikut soalan. Tapi kalau jawapan yang kira-kira selalunya 2 decimal places. Okay, so for this case, sebenarnya kita kena hilangkan dia punya square. Kita kena hilangkan dia punya square. Kita kena hilangkan dia punya square. So when I want to get rid of it, I have to square this guy. Sorry, I want to get rid of the square root. So I have to square. So this becomes t squared for pi squared L over G. Okay, so if I were to try to make sense of it, y equals to mx plus c. Where is my c in this case? T is my dependent. G is my m. Where is my c? Where is my y-intercept?
4 pi square.
4 pi squared. Okay, ada jawapan lain tak selain 4 pi squared ni? What is my C in this case? No one? So everyone agrees it's a 4 pi squared,
Or maybe no C.
or maybe no C.
Zero.
Okay. So what do other people think? Is it a 0 or is it a 4 pi squared?
0.
0. Okay. 4 pi squared. Okay, so kita ada percanggahan pendapat kat sini. So if you guys notice, y equals to mx plus c, ada simbol tambah kat sini. So it can either be plus or minus c. So in this case, kat sini tak ada plus minus tu. This is darab. So it's not the c. So your c here is a 0. Jawapan 0 tu betul lah. Okay. So what does the 4 pi squared become? It's basically just a value. For example, jadi kita tengok v equals to u plus 80, right? So v equals to u plus 80. I can say v equals to 0 plus 20 80. The gradient is still a. The 2 does not affect it. It's just part of the equation. It's just a value. So in this case, for pi ni mungkin nampak macam simbol, but actually pi is a value. Pi is a value just like number 2. Pi is a value just like number 4. So 4 pi squared is basically just a value that you multiply with your gradient. So your C in this case is a 0. Okay, I hope that's clear. So when your C is 0, let's go back to this equation. When your C is 0, so y equals to mx plus 0, how should I draw my graph?
Directly proportional.
Directly proportional, okay. But where is my C?
0.
0,
Dekat 0, right?
Dekat 0.
So it should go over here. So this is where it should intersect, okay. And this is when you have a y equals to mx plus 0 or just y equals to mx. Okay. So I did number 1 with you guys. So I hope that is clear. Apa lagi yang saya nak kena go over supaya tak confuse. Yang ni kena buat sendiri. Akan ada video to guide you guys on doing this. So don't worry. Boleh tanya juga kalau tak faham. Apa lagi? Okay, transform the equation like I showed you before. T squared equals to 4 pi squared L over G plus 0 if you want to add the C, and then tulis what is the y-axis, T squared. What is the y-axis? It was, what was it? Sorry, the y-axis is T squared. T squared. So T squared. What was the y-axis tadi? L, saya dah buang lah pula. L kot. L, and then the gradient is, dia dah kasih sebenarnya. You just have to transform it and macam confirm balik. What is the y-axis? Ni macam hint lah. Ni bukan jawapan sebenar-benar. Ni macam guideline. You have to transform the equation and make sure benda ni betul. Ada squared ke, ada log ke, stuff like that. For this guy, basically you have to convert it into a log because E is not a straight line. And then this guy is a straight line. This guy, I don't know because ada R squared. So you have to try to plot it first. Tengok kalau dia bukan straight line, maksudnya kena convert jadi straight line. Buat square ke, buat log ke. Okay. So that is the method that we are using here. The intercept is 0. And the transform equation is T squared 4 pi squared L over G. Okay, so that is your first question. Transform the equation, fill in the table, sketch your graph. Sketching means rough drawing. Okay, for example, I have T squared versus L here. T squared, tapi korang buat lawa-lawa sikit jangan ikut saya. T squared versus L. Do we know what T is? We don't know. Do we know what L is? We don't know. So if you know, you have to put in length and meter, the units. But in this case, we don't know what it is. It's just an equation, so you don't have to put it. And then rough sketch, the C is 0, right? The C is 0, so this goes over here like that. Okay, so that is your first one. And then number 2, number 3, buatlah sampai habis. So that is sketching. Then the next question is, what graph is to be plotted? Yang ni dia akan ajar korang how to transform the equation. Ada video nanti saya akan bagi. And then find out what is the x, what is the y, what is the gradient and the intercept. And then complete the table using the equation that you transform. Complete the table lah. Plot your graph in to be. So the word used here is plot. When you say plot, you either use a graph paper because it has to be accurate, use a ruler, or you can use your Excel or Word. Asalkan accurate. Asalkan scale betul. Okay, use your graph to estimate the value of E over M, which is your gradient. Yeah, that's your gradient. And then show your calculations. Okay, so where is, ini ada graph paper kalau korang nak pakai, you can use a physical graph paper and lukis pakai pencil, pakai ruler. Let me show you where to find the video. Yeah. Where is my Google Chrome? Let's see. Manual. Semua dekat Putra Blast, Putra Blast. Sekejap. Tak boleh tunjuk. Kat situ saya ada linkkan video. Tapi saya tak boleh buka sekarang. So please go over to your Putra Blast and look at the video. You can go into your groups now. Class is done. If you have any questions, you can ask me through Telegram or WhatsApp. You should go into your groups now and take a screenshot and upload it to the Putra Blast. Go to your Putra Blast, download the worksheet and start working on your lab report. Okay? And then ada video to guide you on how to do it as well. Dia 2 video. Satu 15 minutes, satu lagi 3 minutes kot. Sikit je. Okay, bye guys. I think that's it. Unless you have any questions. Miss, due date bila? Okay, 7 days from now. 7 days. Okay, so find time with your group to do it. You can do it immediately after class right now. Or you can like find time waktu lain pun boleh. Okay, 7 days from now before the next lab or tutorial session. So before 10 AM. Okay, that's it. Bye-bye guys. Talk to you later. I think we have class tomorrow, right?
Thank you, Doctor.
Okay, bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Welcome.